I'm speaking with Vance DeFelice, Senior Global Sales and Marketing Manager at Metglas, who is going to talk to us about the benefits of amorphous metals for aerospace applications. Vance, please tell us a bit about how amorphous metals can be used in aerospace applications.
Metglas amorphous brazing metals are used in the aerospace industry, primarily high temperature applications. Those can include felt metal seals, honeycomb structures, heat exchangers, turbine repair, and even some parts of the engine builds.
Can you explain what nickel palladium is and how it's used in these applications?
Nickel palladium is a precious metal, very expensive. Our nickel palladium alloys contain roughly 36 to 46% of this material. We pair that with some boron and some silicon that will depress the temperatures, and the remainder of that alloy is nickel. It has excellent amorphability. This leads to a very narrow melting range, and it also helps increase the wettability for superalloys, and it will create a very ductile, strong joint with melting temperatures below 1,000 degrees C.
What benefits does amorphous metal technology offer over more traditional technologies in this field?
Traditional technologies typically focus on brazing powders or pastes. Since these are more of a free-flowing material, they require a binder to adhere them in place. They'll basically stick to the base metal where they are needed, but because these binders have to be burned off, they're an organic compound, they have the potential to create pockets or voids in the finished brazing joint. They certainly can contaminate the furnace and must be placed in place with fairly large amounts of material per joint, which will lead to wasted material in the end. The brazing foils themselves are typically very thin, have very consistent thickness, and they can be placed anywhere, tack welded into site, or maybe just sandwiched between two layers of the base metal. They do not require any binders, so the joints are much more uniform. Foil itself can be stamped or bent into almost any shape that's required to braze whatever surface area you're looking for.
Where do you see aerospace manufacturers taking this technology in the future? And where does Metglas fit into the picture?
Well, aerospace, much like we see in automotive today, has a focus on increasing fuel efficiency. So their engineers are pushing the designs for lighter weights and also forcing their engines to operate at higher temperatures. In order for the braze joints to remain strong at those temperatures, manufacturers are focusing a lot of research in the transient liquid phase, or TLP, diffusion bonding process, and that's where they can use a very thin layer of joining material like our foil, which can be placed between two parts, heated for a very long period of time at high temperature. The thin layer of foil then acts more like a catalyst to diffuse the two base metals into one another, and the end result is a braze joint that's practically indistinguishable from the parent material. This basically allows both base metals to have the same properties and develops a very strong joint. Metglas is also developing a few nickel, cobalt, chromium alloys, which will also benefit with the TLP process.
Thank you so much for taking the time to speak with us today, Vance. For more information about amorphous metal technologies, visit Metglas at www.metglas.com.